Good morning, everyone. My name is Ansar Sheikh, AAA Department, St. Peter's Engineering College. Today I am going to discuss about electric heating. In utilization of electrical power, we are having basically these are the following units we are having: electric drives, electric heating, and electric welding, illumination, electric traction 1 and electric traction 2. These are the main units we are having in this unit. In this, here we are going to discuss about electric heating. What is electric heating? What is the principle behind it? Already we know that how heat we are going to when produce, or how the heat will be going to when generated in the point of electrical system is that whenever the loss will be occur. What is the loss means? I square R loss. That loss will be going to be converted into heat. Electric heating is nothing but it is a process in which electrical energy is converted into heat energy. That means here we are doing a conversion of electrical energy into heat energy. That electric heating works on the principle of Joule heating. That means Joule heating is nothing but whenever the current will be flowing through a resistor, it converts electrical energy into heat energy. Here, what is the on which principle the electric heating will be depends is nothing but electric heating is based on the principle of that when electric current passes through a medium, heat will be going to be produced. Let us take the case of a solid material which has a resistance of R ohms and the current flowing through that is I amperes and for the time period of t seconds, so that the total heat generated will be equal to I square into R into T. Very simple. How much heat we are going to be generated, or how much heat will be going to be produced is nothing but that will be going to be equal to H is equal to, that means heat generated or heat produced will be equal to I square RT, where I is the thing but the current flowing through a conductor and R is the resistance of that particular material and T is a time period. That is that much of heat will be going to be generated. Here, what are the applications of electric heating? Mainly, the electric heating having more applications in domestic as well as industrial applications also. In domestic applications, we are having for example, in our houses we are using a room heater. In case of winter season, we are going to prefer for a room heater for heating the building, for heating the complete room, right? After that we are going to use an immersion heater, that means an immersion water heater to hot the water. And next we are having an hot plates for cooking purpose. Whenever you want to use the use to cook some items, then we are going to use hot plates. And geysers also domestic applications to heat water, electric kettles to make coffee, all that, electric iron to press the cloths, electric oven for baking products, electric toasters. There are different types of domestic applications we are having. These are the main whatever we are using in our houses, that we call it as domestic applications of electrical heating. These for these room heater, immersion heater, hot plates, geysers, electric kettles, electric iron, electric oven, electric toasters, all we are giving an electrical energy. Whenever we are switch on these equipment, then automatically that electrical energy will be going to be converted into an heat energy. This process we call it as an electric heating, and these are the main applications of an electric heating. Once if you are generating that producing electric heating, that means what is the output of that electric heating is nothing but in these forms we are getting. And industrial application is nothing but in industrial applications also we are using an electric heating. That is nothing but whenever you want to melt the metals, how we are going to melt the metals or join the metals is nothing but by welding. So there also we are going to use an electric welding by using an transformers or by using some electrical equipment. We are going to use an welding by melting of metals. These are the industrial application. There we are going to by using an electric welding we are melting the metals. And molding of glass for making glass appliances, that means in a molding, that means whatever you need to an a design, that you are going to mold that glass by using an electric heating only. And baking of insulator, we are going to use an baking of insulator. Molding of plastic components, similarly some components, plastic components we are going to mold. And a heat treatment of pointed surface, making of plywood. In some cases if you want to make an a plywood, at that particular time also we are going to use an electric heating. These are will be comes into an industrial applications. Advantages of electric heating over the method of heating. There are, we know that there are different types of heatings. In olden days we are going to use an wood. After that we are going to use some gas. After that we are going to use some kerosene stove. All these, apart from that, nowadays we are going to use we are more convenient with an electric heating. In our houses we are using an induction stoves, electric rice cookers, like that we are going to use. Why? Because the main for example, if we are taking an electric rice cooker, just we are placing the rice and we don't bother. Automatically whenever the rice boil, automatically the switch will be going to be into a warm position. But in the case of wood or gas, or if you are taking an kerosene, then we need a continuous concentration we need to put on that particular food item, whether it is heated or not. Whenever it is boiled we need to move the plate like that. But in the case of electric rice cooker we are not doing so. That are that is the advantage of electric heating. Like that we are having different advantages of electrical heating over other method of heating is in the first and foremost is that it is a clean and atmosphere free from dirt. The no pollution will be there, no flue gas will be produced, response is quickly, uniform heating, accurate control temperature. That means an induction stove, we are what we are doing induction stove, we are going to make the temperature 200 degree temperature or 100 degree temperature, whatever it may be. That means once if it will be boiled, then automatically we are getting one buzzer, then we are going to stop that stove. Like that we are doing. Overall efficiency is much higher. Why? Because of uniform heating, high efficiency of utilization, cheap furnaces, mobility job is nothing but we can take that induction stove or electric heater or electric kettle, we can take anywhere. That is, and mobility is very easy. So that these are the advantages of electric heating over other method of heating. Next, transfer of heat. Here there are, as we know that there are three types of heat transfer methods: conduction, convection, and radiation. Conduction is nothing but this phenomenon takes place in either it may be in a solid, liquid, and gases. Heat transfer is proportional to the difference of temperatures between two phases. No actual motion of molecules. That means from one body to another body, if the heat will be going to be a transfer, that process we call it as a conduction. Convection is nothing but this phenomenon takes place in liquid and gas. Heat is transferred due to actual motion of molecules. Radiation. This phenomenon is confined to surfaces. Radiant energy emitted absorbed is dependent on the nature of the surfaces. For example, we are taking a sun. From the sun we are getting a sunlight. and our surface will be going to be radiated or heated. There are different types of electrical heating. In that we are having two main things: power frequency heating and high frequency heating. Again, in power frequency heating we are having two types. First one is resistance heating and arc heating. In resistance heating, direct resistance heating, indirect resistance heating, arc heating, direct arc, indirect arc. Coming to an high frequency heating, again you are having an induction heating, that is a direct core induction heating, coreless type induction heating, and second one is a dielectric heating or capacitive heating. Depending upon the temperatures, the classification of heating methods are three types, that is a low temperature heating, medium temperature heating, high temperature heating. Low temperature heating is up to 400 degrees centigrade, that we call it as a low temperature heating. Medium temperature heating is 400 degrees centigrade to 1150 degrees centigrade, that we call it as a medium temperature. And high temperature heating is nothing but if the temperature is above 1150 degrees centigrade, that we call it as a high temperature heating. Similarly, this is a different types of electric heating. Once again, this is a graphical representation. Power frequency means normal frequency, whatever we are having in 50 to 60 hertz, that we call it as a power frequency heating. In that resistance and arc. In again resistance, direct, indirect, and arc also direct and indirect. Next, high frequency heating. In high frequency heating we are having an induction, dielectric, or infrared radiant heating. In induction heating we are having a direct and indirect. There one more is microwave heating, that is an 0.3 gigahertz to plus or minus 300 gigahertz. These are the different types of electric heating we are having. Resistance heating is nothing but whatever you take in a resistance heating. In electrical terminology, whatever you want to heat, that we call it as a charge. For example, you want to heat some wood or some glass, that glass we treat it as a charge. Resistance heating is nothing but resistance heating, best example is we know electric water heater. This method is based upon the I square R laws. Always that whenever the current is passed through a resistor material, heat is produced because of I square R laws. The generation of heat is done by electric resistor carrying current. Already we know whenever you are having a more resistance element, the opposition it will be opposes the current, the resistor opposes the it will be going to be an oppose the current, so that heat will be going to be an a more heat will be we are having an a more.